Now, how do we do this power flow analysis, which is basically static analysis of the power network? What do we do here? First thing that we need to do is create a mathematical model for the network. For this purpose, as we had already seen when we developed the model for the transmission lines, all the transmission lines are represented by their nominal pi model. In fact, the very short lines can also be represented by just a series impedance, whereas long lines can be represented by an equivalent pi model that we had developed. So, a nominal pi or an equivalent pi can be used for medium line and long lines, whereas a simple series impedance can be used for a short line. We have also seen how we can model the transformer. Transformers are generally modeled by their leakage impedance only. We do not consider the magnetizing and the core loss part, because that is much smaller percentage of the current which is flowing or the power which is going into this shunt part or the magnetizing part, but also because the current in the two elements are almost 90° out of phase. So, the effect of this magnetizing part is not much. Now, we consider bus power injections rather than generation and loads separately. So, what we do is we, as we saw just now, that we find out the injections at each bus bar, which we had seen is equal to the generation minus load at that bus bar. So, we can write the injection at any bus k as Sk. This is the complex power injection, which is Pk plus jQk, and we know this Pk plus jQk or the complex power injection is equal to Vk into Ik conjugate, where Vk is the voltage phasor at that bus and Ik is the current injection phasor at that bus. So, using this relationship, that is Sk is equal to Vk into Ik, we will formulate the equations for power flow. So, once we know this Pk and jQk and we know this Vk, then we can always find out Ik, that is the current injection into the bus, where Pk, as we had already seen, is the real power injection Pgk minus PLk, Qk is the reactive power injection Qgk minus QLk. Now, let us formulate the model for this power flow analysis. In formulating the mathematical model, we need to formulate first what we call as bus admittance matrix. We will see what this actually is. Now, I have taken here a small power system with 3 bus bars. The bus bar 1 is having a real power injection P1 and a reactive power injection Q1, whereas bus bar 2 has a real power injection P2, reactive power injection Q2, and bus bar 3 has real power injection P3, reactive power injection Q3. These buses are connected to each other through lines, like bus 1 is connected to 2 through line L1, 1 is connected to 3 by line L2, and bus 2 is connected to 3 by line L3. Now, if you model these lines L1, L2, L3 by their pi equivalent model, then the circuit will look something like this as shown here, where for a line L1 which is connecting bus 1 to bus 2, Y12 is representing the series admittance of the line, Y120 is representing the shunt admittance of the line, which is basically the line charging capacitance of the line, and at the end towards bus 1. Similarly, Y210 is the shunt admittance of the line at the bus end 2. So, this pi equivalent model is representing line L1, which is connecting bus 1 and 2. Similarly, we have the pi equivalent model for line 2 L2, which is connecting bus 1 and 3, and the series admittance is given by Y13. The shunt admittance part on the bus 1 side is Y130, and on bus 3 side is Y310, and so on. For line L3, we have the series admittance Y23, shunt admittance towards bus 2 is Y230, and towards bus 3 is Y320. Now, if we take these power injections and convert them into current injections, then having this circuit with us, we can now, using Kirchhoff's law, we can write the network equation for this system as shown now. So, if we do that, then we can write using the KCL that I1, the current which is injected here, will be equal to the current flowing through this branch, which will be equal to V1 into Y120, current flowing through this branch, which is equal to V1 minus V2 into Y12, current flowing through this branch, which is Y13 into V1 minus V3, current flowing through this branch, which is Y130 into V1.